So a lot of work recently has been done on what can be called an ontology or the ontology of scientific change, which is essentially our understanding of what sort of elements undergo scientific change, what sort of agents take stances towards these elements, and precisely what sort of stances they can be. So all of that together, we call it ontology of scientific change or the ontology of scientific change. So what I'm going to offer you is our attempt to redraft the Scientonomic ontology. But I have to take a few steps back and start from something I guess many of you are familiar with. So when you take a typical scientific paper, in this case it would be a typical biological paper, what these narratives try to accomplish, they are trying to causally connect different data points. So they give you a story where they causally connect different events together, different data points together. They say these two lead to that, and then that leads to this, then it has repercussions on whatever else. So in this case, it would be probably biological processes, niche construction, organism development, whatever that is. So that's what a typical scientific study aims to accomplish, causally connect different data points. Well, in evolutionary biology, this data is usually collected in a centralized, accessible database. We all know that database is the famous Tree of Life database. So what we have here is essentially a narrative that is based on some data. And this picture holds for many other sciences. If you look into a typical astronomy paper, what you're going to see is there is some attempt to produce and use a certain astronomical data. Once again, there's some kind of a narrative as this star affects this planet, affects that planet, whatever. So there's some kind of a story, an attempt to connect certain data points, tell us a causal story of a certain part of a galaxy. And once again, this data we know is stored in an accessible, centralized astronomical database. Actually, there are many astronomical databases, the European one, the famous SIMBAD. There's also a whole bunch of different databases by NASA, NED being one of them, and there are many other databases. Now, take a typical paper from our field, history of science. Never mind that it looks ugly, but once again, these papers are trying to tell us a story, a certain narrative, and you get the same picture. Except the question is, where is our historical data being stored? And this is where the situation becomes very complicated. Well, you can say some of it is stored in the personal archives. I want to be very generous here and not to say, well, in many cases you're just dealing with people collecting text over text and producing text. I know some of them do produce data, some of them do collect data. Like these are the events, this is what happened, these were the communities, this is the sort of things they believe. But inevitably, historical data on different epistemic agents and the stances they took towards different theories and methods is currently not collected in an accessible, centralized database. I don't think this is up to debate, this is just a basic state of affairs that we're all dealing with. If anything, I would say this approach is somewhat wasteful. There's so much useful data laying there dormant, and something needs to be done about it. So my diagnosis is that most historical data is not easily accessible and is not reusable by other scholars. So this is what we're dealing with these days. And I would say we can all agree that there must be a better approach. Ideally, you want to have papers which still tell you a certain narrative, and yet the data is collected in a centralized database. So not only do you contribute to a certain story, which is eventually the product of a historical study or observational scientonomic study, but you also contribute to the possibility of reusing that data in future research. So effectively, as an observational scientonomist, you produce two things. You produce an interesting story, but you also collect your data in a centralized database such that can be checked, rechecked, reused, challenged, changed, and so on, just like they do in astronomy, in biology, and all other fields. We have to first deal with the question, what would it take to create such a database? And in fact, we don't really have all the elements in place, all the tools in place to move towards the actual creation of a database. So I'm going to give you an idea as to why is this current situation drastically different from what we want it to be. And here's the reason. I think we can all agree that no centralized database is possible without an accepted theoretical foundation. At the very minimum, you need some kind of an accepted taxonomy and also hopefully some laws. So in the case of biological tree of life, when you reconstruct the tree of life, you rely on the accepted biological taxonomy. What is organism, what is gene, and so on and so forth. So there's certain vocabulary that all sorts of different studies share such that their output can be brought together into a centralized database. The same thing in astronomy. When designing an astronomical database, you need to have accepted astronomical taxonomy and laws. You need to have a basic taxonomy of galaxies, planets, stars, whatever. You need to know what those basic categories mean, what sort of features they have. So before we start gathering data on, say, galaxies, we need to decide what features of galaxies we are going to focus on, what columns our table on galaxies will have. So the records will be individual galaxies, right? What are you going to have in the columns? This requires an astronomical taxonomy. You cannot decide this ad hoc. You need to have some kind of a theoretical understanding as to what sort of features these types of objects have. And this is what astronomers do. The table which stores data on individual galaxies most likely will include a galaxy's mass, size, right ascension, declination, redshift, distance, and so on and so forth. So all of these features are suggested by the accepted astronomical theory, because we believe that all the astronomical objects, all of the galaxies will have those features, and therefore it makes sense to go out there and collect exactly these data. So these features are dictated by the taxonomy of the accepted astronomical theory. Now, in addition, of course, it's not just a taxonomy. Some of these data points are immediately observable through a telescope, whatever means, but other types of data are observable in a sense that you can deduce them or you can calculate them based on other observational data. Let's say the mass of the galaxy. There's no way you can directly measure the mass, so what you do, you take your laws that you know describe the system, which allow you to calculate the mass based on other parameters that you observe. So this is what happens all the time. Now, if you want to put the laws aside and only measure what is directly observable, you can still do that, but at the very least, you need a taxonomy. So that is mandatory. Laws, they give you the additional flexibility, the additional data based on your theory. Of course, it's going to be theory-laden, just like everything else is, but that immediately increases your empirical basis. Now, any data is based on the respective accepted theories. This is essentially the idea of theory-ladenness. Now, the question is, what taxonomy and laws are historical observations based on? Not what they should be based on in the future. What do we have these days? And these days, I think it's safe to say, if you were to zoom in into those multiple studies, you'd see that instead of relying on a unified taxonomy, different studies often use different terminologies. You would have taxonomy 1 here, another taxonomy here, another taxonomy here. So you have a whole bunch of different taxonomies abundant in literature. And this promotes an ever-increasing conceptual vagueness of our narratives. We know this phenomenon. I'm just going to give you a quick example. This is from the Cambridge History of Science volume. I just want to read it for you. Ultimately, it was Newton's work that commanded the greatest scientific authority throughout most of Europe by around the middle of the century. But even though in the field of celestial mechanics and to a lesser degree terrestrial mechanics, Newton largely reigned supreme, in other areas of science, notably those based on experiment, his shadow fell more lightly. In France, the experimental sciences proceeded without any firm commitment to Newtonian concepts. Pay attention, these all seem to be different stances that a certain community can take towards theories. The equivocal attitude of Leonhard Euler towards Newton's theory of light, ranging from an overtly anti-Newtonian rejection of the particle theory of light to a subsequent depth to elements of Newtonian mechanics in formulating his wave theory of light, is another instance of the partial and provisional character of the Newtonian hegemony of the second half of the 18th century. Now, the question immediately arises for Scientonomists, are these all different stances, or some of them are the same? This is a typical case of a vague vocabulary in use. Like your scientonomic instincts immediately tell you something is amiss here. Are they talking about acceptance? Are they talking about use? Are they talking about pursuit? Are they talking about some other stance? What's going on here, right? So this is as though an experimental physicist were to confuse mass, weight, heaviness, and other terms that sound the same but may or may not have the same meaning. So to avoid confusion, we need a systematic taxonomy, or you can call it ontology if you want. There are slight differences, I'm not going to delve into that, of epistemic stances. That's what we need, an ontology of epistemic stances. In addition, because these narratives nowadays, they don't rely on any accepted general theory, what they end up doing, they still have to tell you a causal story, right? They still have to tell you a narrative where some events lead to some other events. Now, how do you ever connect two different events? The moment you say something happened because something else happened, the moment you use that word because, there is a general assumption in place. You can't connect causally any two events together unless you assume something general. Let's take some examples. Here's a fragment. Newton's experiments with prisms, and more particularly the conclusions he drew from them, caused a flurry of controversy when they were first published in the 1670s. And here's the key part. In France, his ideas were actually rejected for a generation because his experiments could not be replicated. What's the tacit assumption here? The tacit assumption seemed to be along these lines, that replicability is somehow important for theory acceptance. And immediately, as a Scientonomist, you can ask, is this meant to be a general feature of science? Or is this meant to be only a part of the method of the time? So is this a general feature, or is this a changeable feature of the method employed at the time, right? But you're not going to find the answer to this question anywhere in this narrative, because this narrative seemingly tells you a story without openly relying on any general assumptions. Yeah, you can't rely on any open assumptions here, but you squeeze them into your narrative from the back door. That's what happens. Here's another example from the same volume. Kepler's so-called second law was not so much an empirical law as a consequence of Keplerian dynamics. It had been generally rejected early because of mathematical difficulties it entailed. Once again, what does this tell you? That the narrator, the author, takes something along these lines as his assumption, that the mathematical difficulties can lead to the rejection of a theory. This seems to be a general assumption here. Once again, we don't know whether this meant to be a general feature of science or a local generalization for that particular community at that particular time, right? So we don't know unless this is openly formulated. Now, what do we have? Ideally, we want to move from this unfortunate practice to something that resembles the most successful scientific practices. From this to this. The data that our studies produce or drawn should be stored in an accessible centralized database. And to produce such a database, we need an accepted taxonomy and general laws. Once again, if you're a historian and you don't really care about how these elements, agents, stances change through time, okay, forget about the laws. At the very least, you need a universal taxonomy. So that is the bare minimum. So at the very minimum, we need an agreed upon ontology of epistemic agents, epistemic elements, and epistemic stances. And this is the part which you can call Scientonomic Ontology, and I'm going to explain that. So in any historical episode, what you have certain epistemic agents that take different epistemic stances towards different epistemic elements. If we take the contemporary Scientonomic Ontology, it would probably suggest you the following picture. It would tell you among agents, we only accept communal agents, communities. There might be other agents, I don't know, individual, artificial. We have an open question about artificial agents. We have an open question about individual agents. But at the moment, our ontology only contains one type of agent, that is community. Communities can accept, use, or pursue theories, or they can employ methods. So this is the ontology that we're currently working with. This is our language. This is our taxonomy. But effectively what you have, different epistemic agents taking different stances towards different elements. So the Scientonomic Ontology tells us what possible epistemic stances can possibly be taken by different epistemic agents towards different epistemic elements. And a typical historical record of our database would tell us what stance an agent took towards a certain element at a certain time period. And here is a typical acceptance record. So you have to mention an agent, let's say British natural philosophy or physics community. The element would be, let's say, the law of gravity. The stance would be acceptance. And the time period would be approximately since early 1700s until 1920 when it was replaced by general relativity. So something along these lines is going to happen in your database. So these would be the columns, the agent, element, stance, from, till. This would be the columns of your database. And a typical employment record would be similar. You have to mention the agent, the element, let's say hypothetical deductive methods. It was employed since circa 1700 until present. Once again, we don't claim that these are actual accurate historical records. This is just for the sake of argument, to give you an idea. Now, the thing is, before we begin any large-scale data collection, we need to be confident that our Scientonomic Ontology of agents, stances, and elements is well refined. You don't want to discover halfway through your massive data collection that, in fact, you're missing something very serious in your ontology. Of course, because this is an empirical fallible enterprise, this is always going to be flawed. Nothing is perfect in empirical science, we know that. And yet you want to take your time to refine your ontology to such a degree that eventual modifications are kept to a minimum, or at least you don't have to start the whole data collection all over again. So you want to be pretty confident that you have a decent ontology to move forward. And I think we find ourselves these days at that very spot. We want to make sure that our ontology is well refined. Unfortunately, or luckily, we have good reasons to believe that our ontology is deficient and it needs to be modified. So I'm going to give you an idea as to what's wrong with the current ontology and what can be done to correct it. Let's start back in 2015, and the basic ontology that you find in the laws of scientific change included two basic elements. Theories, defined as a set of propositions that attempt to describe something, and methods, defined as a set of requirements for employment in theory assessment. So this is where we started. This is what became accepted by this community when it emerged. Then you remember that initially theories only included descriptive propositions. Normative propositions were left out of the mosaic because we had a paradox of normative propositions. This is well documented. We have a video about that. And it wasn't until 2017 when Zoe's suggested solution to the paradox of normative propositions became accepted by a community. That's when it became possible to bring normative propositions into our ontology. So effectively, the definition of theory was modified, just any set of propositions. And it was also accepted that theories can be descriptive or normative, right? Descriptive theories are the ones that attempt to describe something. And by describe, we mean the broad definition of describe that includes explain, predict, everything descriptive, right? And normative theories that attempt to prescribe. Once again, prescribe is taken in the broad sense. Evaluate, assess, everything that has to do with normativity. This change effectively made it possible to include methodologies as normative theories that prescribe the rules which ought to be employed in theory assessment. And this is effectively the current state of our official ontology as you will probably find it in the encyclopedia. This is where we currently stand. Theory, method. However, those of you who actually have had a chance to work with the encyclopedia itself, you couldn't help noticing that the ontology of categories implicit in the encyclopedia itself is very different from our official Scientonomic ontology. So what we actually do is very far from what we theoretically, officially preach. So this is a typical page from your encyclopedia on the current version of the second law. If you scroll down, you notice that this acceptance record shows that the law has been accepted by Scientonomy community since late 2017. The second law is a theory that attempts to answer the question concerning the mechanism of theory acceptance. So this is how this data is stored in the encyclopedia. If you click on this topic page, Mechanism of Theory Acceptance, that's the topic page, the question page to which the theory tries to answer. We use these categories interchangeably: question, topic, issue. And you click on all theories, you see that two different Scientonomic theories have attempted to answer the same question. So this is the ontology you have in the encyclopedia. You have a theory. Every theory is an attempt to answer a certain question. And many different theories can attempt to answer the same question or topic. We also know that each historical instance of theory's acceptance is fixed in an acceptance record. So this is what happens to a theory historically. This is a typical historical record. So formulation of the second law, the authors, the year when it was formulated, and whatever topic it attempts to answer, right? So this is a typical record of the theory in a database of our encyclopedia. And this is its acceptance record. In this case, it would include the agent. The agent is Scientonomy community in this case. The element is the second law, this particular version of it. The stance is acceptance from November 29, 2017 until present. So this part shows the propositional content of whatever the theory is trying to say. And the acceptance record tells you the historical fate, whatever happened to it. And the same theory, we know that can be accepted by different epistemic agents at different times. And that's why it's important to separate the propositional content of a theory from its historical fate, whatever happens to it historically. We can take an actual case from the history of science. So if we take a law of gravity, that would be the record of the law of gravity in the database. It would have an acceptance record, let's say for British natural philosophy community, it would be accepted since approximately the early 18th century, and for the French natural philosophy community, it would be around 1740s. So same idea, the same theory, accepted at different times or different communities, right? Now, this UML class diagram correctly depicts a fragment of the ontology implicit in our encyclopedia. And as you can see, if you compare this with the ontology currently accepted, officially accepted in theoretical Scientonomy, there's a huge gap here. And we find this gap problematic because if the encyclopedia and later the database that will grow from the or grow off the encyclopedia are meant to be based on the findings of theoretical Scientonomy, then at the very least, our theoretical ontology should be in accord or in tune with the ontology that is used to collect data, right? So this is not just an idle practical issue. This, I think, shows us that there's something amiss in our theoretical understanding of the ontology. I don't think the problem is with the Encyclopedia's ontology. I think that's the right way to go forward. But I think our theoretical ontology should be modified to reflect what we actually do. So we currently, many of us, work on reducing the gap between the two ontologies. So this is the current picture, right? This is where we begin. Now, the first step is to introduce the category of question or topic. This is the first step to reduce the gap between the ontology that we have in theoretical Scientonomy and the ontology of the Encyclopedia. This is specifically a modification that is suggested by Rawleigh here. So Will argues that questions and topics, they are not reducible to either theories or methods, that they are an independent element, that you cannot express the propositional content of a question either as a theory or a method, that is a completely different element. So that's the first thing. So the addition of questions is important as they too change through time. It's not just the answers to questions, not only the theories that change through time, but questions themselves. Let's take some examples. As a typical picture of the Aristotelian medieval cosmos, it was quite legitimate at the time to ask as to what's the distance between the center of the universe and the sphere of stars. These days, not only we don't accept an answer to this question, we no longer think that this is a legitimate question. So this question is rejected. At the time, it was a legitimate question, regardless of whether they had an answer to that question or not. So that's the important part. So you can accept a question without accepting an answer to it. I guess we do that all the time in our practice. Look at the list of our open questions, right? So fast forward 200 years, the middle of 18th century, the theory of phlogiston. One could legitimately inquire about the properties of phlogiston. What sort of features, what sort of properties phlogiston has, right? Once again, these days, not only we don't have an answer to this question, we don't accept this question as legitimate. In fact, some of the questions that we nowadays accept as legitimate, such as how is it that species evolve through time and what is the mechanism that guides the evolution, these questions wouldn't be accepted even 300 years ago. So we understand that questions too change through time. And because of that, we have to appreciate that questions are a distinct element in our ontology. So that's the first change. That's the change suggested by Will. There's another problem that has arisen in the context of the encyclopedia. Here's a problem that we see. How should you store methods in the encyclopedia? Those of you who work with the encyclopedia, you know we don't have a single method entered in our encyclopedia. And why is that? Because we don't know how to enter them. While this might be an important practical question stemming from the need to document different methods in the encyclopedia and eventually in a database, it also has important theoretical repercussions. Let's first appreciate that there might be several competing methods that provide different criteria for evaluating theories of a certain kind. Think of, let's say, single blind trial method versus double blind trial method. Surely they are attempting to answer the same question, they accomplish the same task differently, right? They are competing methods. Therefore, I think it's safe to say that each method is an attempt to answer a certain question, certain topic. The only question is, what kind of a question does a method attempt to answer? And once we settle this, we'll probably understand something about the nature of methods. And this is what I believe led to an interesting discovery. These are your methods, these are your questions. I'm going to give you a typical method. A drug is said to be therapeutically efficient if its effect has been confirmed in a single blind trial. A typical method. Here's another one. A drug is said to be therapeutically efficient if its effect has been confirmed in a double blind trial. Now, what question do these methods attempt to answer? I guess we can all agree that it can be roughly formulated along these lines. Under which conditions should a drug's therapeutic efficacy be accepted? So this is a type of question that a typical method attempts to answer, right? But pay attention, this is a normative topic, this is a normative question. It's about ought, should. So every method, therefore, is an answer to a normative question concerning how a theory of a certain kind ought to be evaluated. This can be a very abstract method, like theories in general are acceptable if they have confirmed novel predictions, or a very specific method, like a surgical technique is said to be efficient if blah, blah, blah. So there might be very general methods, very specific methods, but they all attempt to answer a normative question as to under which conditions a certain theory ought to be accepted or ought to be considered acceptable. But if methods are answers to normative questions, then aren't methods themselves normative propositions? Because if the question is a normative question, the answer to a normative question is a normative proposition, right? It tells you how things ought to be or what you ought to do. Surely, if that's how things are, then therefore methods are normative propositions. Indeed they are, since any method is an attempt to answer a certain normative question, therefore any method can be expressed as a set of normative propositions. And therefore, and this is the drastic part, methods are not completely independent from theories. They are indeed a subtype of normative theory. They're not here, they're here. They are a subtype of a normative theory. They may or may not be explicitly stated. I'm going to cover this part. But whether something has or hasn't been explicitly stated, we know this concerns the historical fate of a proposition. The propositional content of it is normative. It's a set of normative propositions. That's what it is, effectively. Now, this surprising finding also makes apparent that once written down, methods and methodologies are virtually indistinguishable. There are some differences between the two, but those differences are not in their propositional content. So methods, traditionally we have understood them as the actual or often tacit, often implicit expectations of a certain agent. And methodologies, we traditionally understood them as being openly, explicitly stated by the agent as the right way of doing science, right? So this is what they do and that's what they say they have to be doing. So that was the distinction that was very important for Scientonomy early on going forward. Now it turns out that from the perspective of the propositional content, the two are essentially the same thing. The only difference is that one becomes accepted, the other becomes employed. That's the only difference. But propositionally speaking, both are trying to say the same thing. They are an answer to a normative question about under which conditions a theory is acceptable or compatible or scientific or whatever, right? You take method, methodology. Whatever I formulate as a method can also be formulated as a methodology. Astronomical data is acceptable if it has been obtained by a healthy human eye. Can be method, can be methodology, depending on historical circumstances. Propositionally, there's no difference. The only difference is in their respective historical fates. These ones become employed, those ones become accepted. But the historical fate is not a good reason to discriminate between different types of ontological entities. It's the propositional content that should guide us in our classification of epistemic elements. So therefore, we need to reconceive our notions of method and methodology, and this is the next drastic change. From the ontological perspective, we are dealing with the same class of elements, which can be both accepted and employed. We don't need two classes of elements here. One class would suffice, and we will use method to denote this class. And so from the ontological perspective, we're dealing with the same class of elements, which can be both accepted and employed. So the same method can be accepted by an epistemic agent as the correct way of doing science, and it can also be employed by an agent that is become the agent's actual expectations. Let's take an example. So let's take the hypothetical deductive method. A theory is acceptable if its predictions have been empirically confirmed, some kind of a sloppy formulation of it, doesn't matter in this case. It can have an acceptance record. Let's say in British community, it was accepted as the right way of doing science since the 1830s, okay? But a case can be made that they employed this method much earlier, since the early 1700s. Once again, these are not necessarily accurate observational scientonomic records of this. Only a proper observational research will show whether these are correct records. So the same idea, but it can be accepted, it can be employed. You don't need two classes of elements here. Now, importantly, this strategy allows to clearly delineate the propositional content of an element from its historical fate, from its historical record. And this is absolutely important as far as the historical database is concerned. Because in a database, you have to do that for every type of element. You have to be able to formulate the element independently from whatever happened to it in history. Because the same element can have different fates in different communities, right? The same law of gravity can have very different fates in different places. The same hypothetical deductive method can have very different fates in different places. But you need to have the ability to formulate the method itself without mentioning any part of the history. So this is what we have. We have to separate the propositional content from the historical record. Now, one question that arises here, is this ability to be both accepted and employed, is this peculiar to methods only? Or can we say that normative theories of all types have this ability of being accepted and employed? To begin with, we know that all theories, the theories of all types, have the ability to be accepted, right? You can accept them. Now, the choice is this. Is this capacity of being employed, is this exclusive to methods? Or can we say that normative theories of all types have this capacity, and therefore, if you say all normative theories have the capacity of being employed, then that applies to ethical theories, aesthetic theories, and methods themselves, right? So the choice is this: either only methods have that capacity or all normative theories have that capacity. Now, I would say it seems reasonable to suggest that the capacity of being employed and not merely accepted characterizes not only methods, but all normative propositions, including those of ethics, and I would add aesthetics as well. I've done some research, and it turns out that people who study these things, they recognize this as early as the 1930s. So the difference between accepting an ethical norm, for instance, and acting upon it, like employing it, to use our language, in practice has been well documented as early as 1934. There's a famous study by Richard Lapierre who studied American prejudices towards the ethnic Chinese community, and be surprised by his findings. He showed that it's one thing to accept the norm one ought not to accommodate guests of ethnicity X in one's hotel, and it's quite a different thing to employ that norm and actually refuse accommodating guests of that ethnicity in practice. So accepting the principle of racial equality is one thing, actually employing it in practice is another thing. Okay, we want to reduce the gap, but theoretically speaking, we understand the difference between the two, right? So it's one thing to accept that killing is bad, it's another thing to actually act upon this norm in practice, so on and so forth. Therefore, I think we can say that normative theories of all types have the capacity to be not only accepted, but also employed. And one final remark about this new ontology is that it's also important to appreciate that all of these stances can be both implicit and explicit. So explicitness or implicitness doesn't really change the stance. And I'm going to give you some examples. So you have accepted, you have employed, and you have explicit and implicit, 4 categories. And you'll see that it doesn't make difference whether something is explicitly accepted or implicitly accepted. For instance, consider an agent, a hypothetical agent, which explicitly accepts this norm. You ask them and they say, all humans ought to be treated equally regardless of their race, ethnicity, nationality, religion, so on and so forth. Suppose this agent starts to critically reflect on their own behavior and soon realizes that in fact they don't always act upon this norm, that in fact what really guides them in their practice is this: not all humans ought to be treated equally regardless of their race, ethnicity, nationality, religion, and so forth. So what you have here, you have an agent who explicitly accepts one thing. They also explicitly employ something in practice. They say, yeah, that's how I act. I shouldn't be acting like this. It's wrong to do that, but that's what I do. Imagine a different agent who never had a chance to reflect upon their own beliefs or their own practices, somebody very down to earth who has no interest in theoretical reflections of this sort. So scientonomically speaking, they don't have any explicitly accepted or explicitly employed norms, okay? However, in their actions, when we observe this agent, he's always extremely respectful towards all people, regardless of how deserving or undeserving these people might be. So we observe and we know that something along these lines probably guides their actions, that one ought to treat everyone with respect, regardless of how deserving or undeserving these people might be. Then we ask them to reflect upon their own practice, and this person says without any hesitation that the respect towards a person should be proportional to the person's merit. In that scenario, we can say just before we ask them, they probably accepted this norm implicitly, the norm that one ought to treat everyone with respect proportional to how deserving or undeserving these people are. So we can legitimately speak of something being implicitly accepted together with implicitly employed. So this applies to norms of all types, including methods. Your accepted explicit methods would be openly accepted methodological dicta. These are the ones you usually find in your textbooks and encyclopedias. This is what scientists believe we have to do in evaluating theories. Your explicitly employed would be the actual expectations of a certain epistemic agent, of which the agent is well aware, but may or may not consider acceptable. Consider a certain community, reflects upon their practice, explicates their method, and they say, well, that's not really the way we should be doing things, but unfortunately this is the current state of affairs. So there might be a discrepancy between the explicitly accepted and explicitly employed. The implicitly accepted is the unarticulated methodological dicta which the agent accepts as the right way of doing science. So you can have implicit beliefs as to what a proper science should be like, regardless of whether you implicitly employ those principles in practice. Right? So these will be your actual expectations of which you're not fully aware. So the bottom line is that the difference between explicit and implicit is not vital here. This is not what's going to help us discriminate between different ontological entities. That's not a characteristic that's going to separate different entities. So similarly, all epistemic elements can be both explicit and implicit. I'm just going to give you a big chart. So this would be a descriptive theories, normative theories, explicit and implicit. We already considered ethical norms that can be both explicit and implicit. We also consider methods. I would say aesthetic norms can be both explicit and implicit. I think this is an easy idea to digest, right? Natural sciences. Yes, we have lots of things that are implicit in natural science. Social sciences, formal sciences. A good example from natural sciences would be the idea that particles have objective values of position and velocity even before they are measured. Now, this assumption was implicitly accepted by physics community as part of classical physics long before it was explicitly formulated by Einstein as part of his criticism of quantum physics in the 1930s. And we know by reflecting on our practice that we do have tons of beliefs that we eventually explicate in our encyclopedia. If you go back to the early days of the encyclopedia, we didn't have topics or theories on our ontology. The whole idea of ontological elements and stuff, it's nowhere to be found in the laws of scientific change to begin with. It's only later on we discovered that, oh, wait a second, these are different questions, these are different theories that we accept, that there are theories, there are methods, that they have such and such features. So all of that needs to be stated separately. So as you can see, implicit and explicit, you find that in any field of inquiry, and that's the point here. Okay, to summarize, these are the changes we suggest. This is the current picture. We think that questions are a distinct class of epistemic elements. Each theory will be considered an attempt to answer a certain question. This is what Will's suggestion is. That the method is a subtype of a normative theory. Questions have the capacity of being accepted or unaccepted, so you can have an acceptance record about a question. So do all types of theories. They also have acceptance records, right? Normative theories, all types of normative theories can be employed or unemployed, so they have employment records. And this is the ontology, a modified ontology of scientific change that we suggest. I suspect it's going to have further repercussions and some other categories will probably have to change. But this new suggested ontology greatly reduces the gap between what we do in the encyclopedia and the theoretical ontology that we preach. Do we have any questions? Jamie?
Thanks, Hakob. It's a clarificatory question about the relationship between questions and theories. Because there seems to be two different ways in which theories are involved in questions. One is that a theory is an answer to a question, like you said, but another is that a question presupposes a theory to even be sensible, and that's why questions change throughout time. So I'm just wondering if you can clarify a little bit, especially why a question is next to theory rather than something that might be subsumed under a theory or something like that.
That's a fantastic question. So I think the logic here is that at this stage we know that questions play an important role. We also have good reason to believe that they're not really reducible to theories because there's some content in questions that cannot be expressed as theories. That's why they have to be a separate element there. That's the reason why they're on the same level, so to speak. That's one thing. So you also inquired about the two types of relations that seem to exist here. Theories are answers to certain questions, but also we can suggest or we can hypothesize that theories play an important role in the acceptance of a certain question as legitimate. For instance, if you believe that there is such a thing as a phlogiston, then it may suggest a legitimate question as to what are the features of phlogiston. Now, these two relations, they seem to be similar, but they are very different in nature. The former is an ontological relation. It has nothing to do with how these things change through time. Any theory is, ontologically speaking, an attempt to answer a certain question because that's what makes it a theory. The second relation between the two concerns how is it that a certain question becomes legitimate. And this has to do with the process of scientific change. This has to do with how something becomes legitimate. And this is something you cannot posit through ontology, through any ontology. An ontology is not about how things change through time. For that you have the dynamics of the theory. So presumably once this ontology is accepted, an important open question immediately arises, which Will suggests in his paper, how do questions become legitimate? So you need a law of question acceptance. So what you're alluding to, you're guessing that there might be a link between the theories being accepted and questions being accepted as a result of that. I suspect there's going to be something along those lines, but at this stage it's anyone's guess because we don't have a law of question acceptance. Other questions? Yeah, Therese?
My question is about the relationship between methods and the normative propositions. Does it matter how the methods come about in that relationship? Like if it's through some sort of trial and error process or some reflection on the part of the experimenter, like does that matter at all?
Yeah, so it's a good question. From on the ontological perspective, or from the perspective of the propositional content of these different elements, theories, normative theories, methods, it makes no difference whatsoever. Effectively, you end up with a certain proposition that is a normative proposition, right? Regardless of how it came to be. If we ever come to the point when we start thinking that the question of the theory generation, or in this case, method generation, method construction, is an interesting question for Scientonomy, then we would have to come up with a certain mechanism that explains how methods become constructed, right? So that will be an interesting question. But propositionally, it's still the same thing, right? There can be many different versions of it, but each one written down would be a normative theory. Does that make sense? Okay, so this new suggested ontology, as I said, reduces the gap between what we preach in theoretical Scientonomy and what we do in the practice of the encyclopedia. And I would say it also brings us a step closer towards an ontology that will eventually be in the backbone of our tree of knowledge database. We're still very far from it, so we shouldn't be deceiving ourselves that we are close to that. The next step would be to run a trial, a pilot project with a small community, relatively well defined, and see if our ontology actually allows to capture those features of those communities that we're really interested in. And I suspect we will discover lots of things, just like our short experience with our own encyclopedia, which is, in a sense, a mini database, right? It's just a database that captures the belief system of a small emerging community. But it's still a database, essentially, that's what it is. The reflection on that short experience, it shows, it reveals that a few things in our ontology need to be reconceived and changed. So I suspect there's going to be similar developments in the future. And we'll probably have a few cycles of refinement before we are in a position to say, yeah, we feel comfortable enough to take this ontology and then use it to describe the belief systems of other communities. Because it works for our community, then why shouldn't it work for other communities, right? So it also brings us a step closer towards the ontology that will eventually be in the backbone of the tree of knowledge database. If there are no more questions, thank you very much.